Hello everybody. Today I'm going to be showing you how to do the predicting products of chemistry reactions homework that we got in Miss Clay's class. So, our assignment was to do only the odd numbered problems. So there's only 7 we'll have to do, 3 through 15. So starting with number 3, it's NiCl3 plus Br2, so that's a compound plus an element, so it's going to be a single replacement. And then for step 2 right here, we're going to write the formula of the products from this equation. So, but first we'll have to check and see okay, so Ni has a charge of Ni is a transition metal, so normally you'd get the Roman numeral for it. But so, since it's in the reactant and it gives you it in a compound with Cl3, Cl has a -1 charge, so Cl3 is going to be -3. So you know that Ni has to have a +3 charge. And then Br has a -1 charge. So, in this single replacement, the non-metals will be switching, not the metals, because there's only one metal. So the product should look like Cl2, because Cl is part of Brinkelhoff, so it can never be by itself, so it's going to be Cl2 plus Ni Br. Now there's going to be 3 Brs because we know that Ni has a +3 charge and Br has a -1 charge. So it's going to be Cl plus NiBr3, and you could do that NiBr3 plus Cl2. Either way works. So then right here where we write and balance the equation, we'll get NiCl3 plus Br2, because Br is 2 right there, also because it's part of Brinkelhoff. And then yields to NiBr3 plus Cl2. Now, we check, will this reaction happen? Since the single replacement, the replacing being done is 2 nonmetals, we check on the periodic table instead of on the reactivity chart because it's 2 nonmetals. So if we look here, Br has less power than Cl has. So Br couldn't beat out Cl. So we know the reaction could not happen. Moving on to number 5, we have CSOH plus H2S. So that's going to be a double replacement because you have 2 element compounds. So then here we write the formula of the products. So first let's check the charges. CS has a +1 charge, which means the polyatomic OH has a -1 charge. Then H has a +1 charge, and there's 2 H's, so it's going to be +2. And then S is going to be -2. So whenever we switch it around, it'll be CS plus 1 charge. So we'll need with sulfur. So we're going to need 2 CS's because sulfur has a -2 charge. So it's going to be CS2S, then plus H2O. Now how did I just change OH plus H to H2O? It's because they're the same thing. You can write it either way, and it shows you right here in this example as well on number 1. So then putting that all together and balancing it. Oh, I didn't balance the first one, by the way, because I forgot. So let's go ahead and do that. So you're going to need 3 Cl2s because on this side you're going to have 2 Cl3s. So then you'll need to put a 2 in front of NiBr3, which means you got to put a 3 in front of Br2. So then that one's balanced. Now let's write number 5 out. Okay, so we're going to have CSOH plus H2S yields to CS CS2S plus H2O, and then to balance that, you got 2 CS's over here, so you're going to have to multiply this by 2, so you'll have 2 CS's over here, but then you're going to have 2 O's, so then you're going to have to put a 2 over here. So now if you check, you have 2 CS's, 2 CS's, O, 2 H's, 2 O's, then 2 H's right here, so that's 4 H's. Over here you have 2 H2's, so that's 4 H's, then 2 O's, 2 O's, and then yeah, so that's balanced. Okay, so now to check if it happens, we have to check the solubility chart because it's a double replacement. So if we look here, we can check S first. So S is normally insoluble, but it is with CS, which is an alkali metal. So that means it really is soluble, because that's one of the exceptions, is the alkali metals. So then we go and look at H2O. And if you notice, H2O isn't even on the solubility chart because H2O is already a liquid. So I'm not sure what you do here, but I'm pretty sure since none of those are going to form a solid, then the answer will be no, since a new precipitate's not formed. So moving on to number 7, you have Br2 plus MnF3. So Mn has a positive 3 charge, plus 3, and F has a minus 1 charge. And over at Br, it has a wow, this is awkward. I can't find it. Then Br is a minus 1 charge, but there's 2 of them, so it's going to be a total of minus 2. So then writing the products, so that's a non-metal, so the non-metals will be switching, not metals. So you're going to get Mn Br. Mn's plus 3 and Br is only minus 1, so you're going to have 3 Brs. Then plus F2 because F is part of Brinkelhoff. And then writing the equation out, we're going to get Br2 plus Mn F3 yields to Mn Br3 plus F3. So, balancing this out, you're going to have to do, since you have 2 Brs on this side and 3 Brs on this side, you're going to have to crisscross. So you're going to get 2 Mn Br3 and then 3 Br2. So then you change the number of Mn's. So then you're going to have to do 2 Mn right there and then 2 F3. So now we're done with that. We balanced it. So now we check to see if it happened. So we're going to see which one of the nonmetals is stronger. If you look, Br is weaker than fluorine, so the reaction cannot happen. So, done with the front, moving on to the back. Okay, so now we have AgNO3 plus CuCl2, so it's going to be a double replacement. Ag has a charge of plus 1, and NO3 is a polyatomic. It has a charge of negative 1. Then CuCl2. Cu has a plus 2 charge because there's 2 Cl's, which is a minus 1, which with 2 of them, that's going to make a minus 2. Okay. So switching, you're going to get Ag, which is a plus 1, with Cl, which is a minus 1, so that's a happy couple. Plus, you're going to get Cu, which is plus 2, with NO3, which is only a minus 1, so you're going to put a 2 subscript after the NO3 polyatomic. So now that's a happy couple. And so now we write the whole equation out. and we'll get AgNO3 plus CuCl2 yields AgCl plus CuNO3 2. So now balancing that out, you have two NO3s over here, so you're going to have to put a 2 right there, so which means you're going to have to put a 2 right there. So now it's all balanced. So we check to see if the reaction will happen, and it's a double replacement, so you're going to check the solubility chart. Okay, so first we're going to check Cl, which it is soluble unless it's a compound with Ag, which it is, so it's going to be insoluble, so you automatically know right there it's going to create a precipitate, so it's going to be yes. So now moving on to number 11, we have a decomposition. So it's gonna go from MnCl to Mn plus Cl2. Mn plus Cl2. So then you write the... So automatically, since that's a decomposition, you know that reaction will always happen, so you can write yes right there. So then you write it out, you're going to get MnCl2 yields Mn plus Cl2. So it's already balanced right there. So now, moving on to number 13, we have C4H10 plus O2. Okay, automatically, you're right there. You can recognize that that's a combustion because it contains C, H, and O, which means you can just look at that and know that the products are going to be H2O plus CO2, which is always combustion. So if we do that, we're going to get H2O plus CO2. And you know that's always what the products will be whenever you have C, H, and O in the reactants. So then writing the whole equation out, we get C4, H10 plus O2 yields H2O plus CO2. Now we have to balance this out. We have 10 H's on this side, so we're going to have to put a 5 in front of the H2O, which gives us 5 oxygens, which isn't going to work because that would be an odd number, so you're going to have to double this. So you're going to get 10, which is really 20 H's. Then you're going to have to double this one too, so you're going to put a 2 right there, 10 right there. So now you have 8 C's, so you're going to put a 8 right there, 8 CO2, and so right there we have 16 O's, right here we have 10 O's. So it's going to be 26. So we're going to have to write 13 O2 right there. That's a little sloppy. So you're going to get 2C4H10 plus 13 O2. Now this is a combustion, so you know it's always going to happen. Same thing for number 15. That's also a combustion, so you know that's going to happen. And then the products are going to be H2O plus CO2. So we balance that out and we get C6 H14 plus O2 yields H2O plus CO2. So we have 14 H's on this side, so by default we would try to multiply this H2 by 7, so we would have 14 H's on this side, but that'd give us an odd number of O's, and you can't have an odd number of O's on that side. So once again we'll have to double, so we'll have 14 H2O, and then on this side we'll have 2 C6 H14, which means we're going to have to have 12 C's, so we'll do 12 CO2, which gives us 24 O's, 24 oxygens, plus another 14 oxygens, which is 38. So we're going to have 17 O2s, because that would give us 38. Just kidding. We're going to have 19. So we're going to have 19 O2s to give us 38. And that's it. Once again, here's the answers. Hope you enjoyed. If this video was helpful, please like it. Thanks for watching.